Table 2, 97, rational or irrational? Okay, class, agree, disagree? Why is it rational? Class. Did you say, what did you say, Abigail? It's a number that ends. All right, so yeah, it's rational. Whole numbers, all whole numbers are included in rational. So like rational and irrational are the two big main categories. Table 1, what about negative 8.2, rational or irrational? Table 1, rational or irrational, the negative 8.2. Rational, and why? Because it ends. I will say there are decimals that go on forever that are included as rational. But we'll tackle those when we get there. But negative 8.2 for sure is rational because it's a decimal that ends. All right, table 8. What about the square root of 5? Rational or irrational? With an I? All right, class, agree, disagree? All right, I also agree. We did talk about how all of the non-perfect square roots are all irrational. So the easiest way, I think, to identify these as rational or irrational, I know that irrational would be a decimal that goes on forever without repeating. Right? It goes on forever and it doesn't repeat. Just like how pi is a decimal that goes on forever without repeating. That one's also irrational. So then if it's not a decimal that goes on forever without repeating, then it's rational. Okay. But then I did mention there are decimals that go on forever, but they do repeat, like 1/3. All right, 0.3 repeating. Is that rational or irrational? Rational, because it repeats. Then even like 2/3, for example, rational or irrational? It's rational with an R. It's just that the calculator, because it only shows so many numbers, will like round the last one, but it is 0.6 repeating, so that one is still rational. It's only if it goes on forever without repeating. Okay, questions on that? All right, so then table 7, what about negative 3/7? With an R or an I? Okay, they say irrational, let's check. So negative 3/7, I don't know off the top of my head. All right, it does look like a decimal that goes on forever without repeating, so yeah. Irrational with an I. Questions? Where? Oh, you mean like here? Like it repeats that portion? Yeah. Okay, let's see what the book says. I didn't notice it as that whole chunk repeating, but you might be onto something. So the book does classify that one as rational for that reason, because there is a chunk that does repeat. So good observation. I didn't notice that. So it technically is rational, but I think you guys are getting like the main point of how to tell. Aiden, didn't I tell you when to go? So don't interrupt me again, ask me again. Know when to go. Okay. So table 5. What about the square root of 100? Rational with an R. Okay, because class, what's the square root of 100? 10. So perfect squares are all rational. Table 4, what about square root of 9/4? Yeah. Irrational with an I. So let's see. I know that the fraction itself is a perfect square, so let's see. Yeah, so since that's a decimal that ends, so I'm not sure how you entered it in your calculator. But since it is a decimal that ends, it is rational. Did you get 1.5 in your calculator? So what you probably would have had to do is put the 9/4 in parentheses and then press the square root button. So yeah, all calculators, it's different. It just depends on which one you have. I say practice with the one you plan to use on the test. All right, and then table 3, what about the negative square root of 18? Rational or irrational? Irrational with an I. So questions on that? And I know that one is because it's a non-perfect square, but I can show you. All right, decimal that goes on forever without repeating. Or chunks that repeat, like how -3/7 said. For the negative part of this, some people might think that it's no solution, but since the negative is outside the square root symbol, it just goes after you take the square root of it. So it's not no solution, it's this, but negative. So questions on that? Good. Okay, so today, well, what we have been focusing on in Unit 7 is solving without graphing technology. In the real world, you do actually have access to graphing technology. So today we're going to practice with the graphing technology. So in your groups, fill out this table for the zeros using graphing technology. So that should be really quick. And it's only 4 equations. I'll give you 4 minutes. Most likely, your answers, because when you put it into the Desmos calculator, it'll round. So you'll have to determine, are my answers rational or irrational based on how it looks in the graph calculator. It's a great way, like this is a great time to practice how to figure it out on the test, how to check your answers on the test quickly using a graphing calculator. So that's the main purpose. Everyone should be practicing these themselves. So just rely on your other table mates to do all the calculating. All right, table 7, what'd you get for the zeros for the first equation? Super easy. This is really testing you on. Can you type? Okay, start over at what? Okay. 0. Okay, just give me the x's. Like, don't give me the whole coordinate. You want me to put -8 also? Oh, that's just like. So -2.828, that's all you got? No. Okay, what else? It's just -8. Okay, class, agree, disagree? Okay, what do we disagree with? Okay, what is it supposed to be? 2.828. Anyone get something different than those now? Okay, so what you should have done is type in y equals, and with Desmos, you don't even have to rearrange it. If you don't rearrange it and it's not equal to 0, then it probably won't look like a U shape, but it will still give you the correct x-intercepts, which is another word for zeros, another word for solution. They all talk about the same thing. So your graph should look like this. So if you see something that looks like this, are my answers rational or irrational? They are irrational, because the graphing calculator will round it, just like how it rounded it at some point. But these are actually decimals that go on forever without reading. I didn't tell you to do number 2, but if you did, number 2 says find the exact solution, so not approximate solution. Notice how in number 1, when I put my zeros, I did it with like these little squigglies, because that means that it's approximately that, not equal to it, because it's a decimal that goes on forever. So when you approximate it, and you really should only be doing that for one problem on your test, for that projectile motion problem, then you use that symbol. But when it's wanting an exact solution, it wants it in radical form. So like for A, here was the problem. And notice that it's set equal to 0 instead of y now, because we're solving for the zeros. At the x-axis, what is always 0? 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 We can do this all day until you guys finally say it. At the x-axis, what is always 0? Does it look like the x is 0? Look at it. That is not, this number is not 0. So that's telling the x. At the x-axis, what is always 0? Y. At the x-axis, what is always 0? No, it is not. At the x-axis, what is always 0?
0.
Look at it. Look at the coordinates.
It's simple coordinate.
Right here. Look at every single thing you touch on the x-axis. What is always 0? So everyone needs to say that. It is April. We talked about this all year. All year. At the x-axis, what is always 0? The y, for the love. I shouldn't hear like, and this happens all day in all my classes. One person understands. So now you all know, if you leave 9th grade with anything, at the x-axis, what is always 0? Okay, great. As you can see, because it goes x and then y. So that's why we're setting y equal to 0, so we can solve for the x-intercepts. And in these ones, I can just isolate x, because there's only one x. So how do I get x by itself?
I'm gonna add 8.
Add 8, whatever you do on one side. Okay, x squared equals what?
8.
Okay, good. And then opposite of squaring is, and then anytime you square root, there is a plus or minus answer. But 8 is not a perfect square. And really, I could simplify that radical, but just for the purposes of this, if I type in the square root of 8, does that match the decimal that I have here?
Yeah.
It does. It shows you like this one has more because it can show more. Over here it's rounded, but that's how I can know that I solved it correctly on my test, is check it in Desmos. Questions on that? Okay, so making sense now, hopefully. All right. Let's see, table 5. What are the zeros for the next one?
4 and 6.
And are they 4 and 6 exactly, like no decimals?
Yeah,
Okay, so class, would that be rational or irrational?
that's right.
All right, and if you did not get that, maybe you typed it in wrong, so. Let's see, I can't see from here. Parentheses, x minus 5, I think. Squared, minus 1. All right, and Desmos is really user friendly. It'll let you click on the x-intercept and it'll stay there. So yeah, that one is 6 and 4. So however you solve that one, you can know if you got 6 and 4 that you did it right by checking your graph. Or you could just graph it from the beginning and I would never know. Questions on the second one? Okay, that one's good. Table 4, what about the third one? What are my answers? While they're calculating it, you guys solve it by hand, you probably already down here. Isolate, yeah.
Five.
5.586, anything else? 8.4. Okay, class, anyone get something different than those? So let's see, so I don't have it memorized yet. Type it into Desmos, zeros are your x-intercepts. So that's where the y is 0, get it? That's why we call these zeros. So those are my x's. So I would agree with that. Now, those are most likely gonna be rounded because they're weird looking decimals. Is that rational or irrational?
Irrational.
So on your test, I would need the exact solution, which you guys would have to figure out either by quadratic formula, by isolating x, by factoring, something. So in this one, since x is only written once, I'm just gonna isolate it. What's opposite of squaring? Square rooting. Do that to both sides. I get x minus 7 is square root of 2 perfect. A perfect square. So then I'm gonna put plus or minus radical 2. And then x is still not alone with opposite of minusing 7. Adding 7, whatever you do on one side. Okay, great. So then I get x equals, you could put it in either order. I'm gonna put it as 7 plus or minus radical 2. And then if I type that into my box, well, really I'd have to put it separately, one where it's x 7 plus radical 2, and one where it's 7 minus radical 2. So that's how I could check my answers on my test, even the irrational ones, to see if it gives me the same zeros as my graph. And does it? Okay, great. Questions on that one? All right, almost done. So last one, table 3, can you tell me what the zeros are? Positive what? So really, I could have wrote that one as plus or minus 8.944, but let's see. That way's fine too. So out here, it's minus 5. And inside it's x over 4, right? Yeah. Okay, so making sure it's really tiny. But yeah, so have a wide looking graph there at 8.944 and at negative 8.944. So we use the graph correctly. Is it rational or irrational? Irrational. Questions on that? All right, to find the exact solution there, again, just isolate x. So we'll do that down here. Sorry, when I write side, like with a split screen, it looks ugly, but we're getting the x alone, starting with what is closer or farther? Farther. So would that be the 4, 2, or the 5? And how do I cancel out a -5? Whatever you do on one side. Okay, great. I have this. What's farther now, the 2 or the 4? Opposite of squaring is, so we're going to do that on each side. So then the square will now cancel out. I have x over 4 equal to plus or minus the square root of 5, because that's not a perfect square. And what's opposite of dividing 4? Multiplying by 4. And whenever you do on one side, this is actually times 4. I don't want to put plus or minus 4, that would be confusing. All right, so it would be this times a positive or minus square root of 5. And if I type that in, I mean, you probably could put a plus or minus in, but I'm not gonna. 4, and then the positive square root of 5 multiplied by it does give us that we talked about. And then if I just make it negative, now it's the negative. Okay, so if you're having to solve, you can check your answers with a graph. Is the whole point of this lesson. So questions on today's lesson? Lesson 20? Okay, so a few announcements, and if you start shuffling all your papers while I'm talking, you're probably gonna miss something important. So we do have a binder check today. I'll be calling you for that shortly. So we just wrapped up lesson 20. So everyone should have at least one paper from their binder check. At least one, because we just did a lesson. Also, because hopefully you have your binder ready already. What you can work on right now are the 2 study guides for your Unit 7 test, which we're taking on Tuesday. So one of the study guides, the bottom one that's right here, the constructed response test, is what you picked up over here. So that'll look like your 50-point portion test. The top one looks like your 100-point portion. If I get through all the binder checks early, I can answer some questions today. But on Monday, come prepared. Have already attempted it so that you are prepared to ask questions on the ones that are actually difficult that you've already tried. So, because that's what we'll do Monday is go over it. Also, we were supposed to have a quiz today, but I made it a take-home quiz. So here's how that will work. The instructions are all in Flugy. So when you click on it, and it's in this big folder. All right, and it's kind of hard to see right now. But it's still gonna be timed. The password is there, it's formula with the capital F. Do not start it unless you're ready to finish it in that one sitting. If you don't have 25 minutes to spare, then don't start it. And then I will disable submissions Sunday by midnight. And so that way people could view their quiz, I'll make it viewable at that time. People could view their quiz, maybe do corrections on it, improve so that they're ready for the test on Tuesday. If you choose not to do it, that's fine. I'll just use whatever score you get on the test on Tuesday. So it's more like extra practice. It is good practice for your test. But yeah, You just don't have time to do it really in class. Do it at home if you want. If you don't do it, I'm just gonna give you whatever score you get on your unit 7 test, so do well on it. I've always made that the deal. That I would replace your quiz scores with the unit test score if it's better. Questions, comments? And if you cheat on it, it's only like a 10-point assessment, so like. It doesn't really make much of a difference. You have 150 assessment points going in next week, so if you cheat on this one little quiz, good for you. It's not gonna make a huge difference in your grade. How about actually try it, so you know what to improve on for Tuesday? Good? Okay, so I'll call you for binder checks starting now.